All right, guys, so in this video, we're going to talk about the different types of sequences that we're going to run into in this unit. A lot of it will be review of Algebra 2 at first, just like our other units, and then eventually things will get a little bit more complicated. But the way that we're going to start is just by talking about sequences, and we're just going to be talking about recursively defined sequences. So you might remember, and hopefully from the homework, you can recall that an arithmetic sequence is a sequence that involves addition or subtraction, right? So it would take this general form, and this is a general form that's going to be pretty important. So for a general sequence, and I'll call it f sub n, this sequence would start with a first term, right? And then there would be a second term, and this would continue. But the relationship between the first term and the second term is the addition of some common difference, right? And that might be a negative common difference if these numbers are decreasing. But these numbers are just going to keep continuing along, and we're not adding them together. That's not what we're doing here. We're just seeing numbers listed, and this common difference is going to be the exact same thing. And this will continue on, a number, and A will represent the value of that term. I don't want to use N here. But this is going to continue over and over and over and over, and the term before this one, before the f of a minus 1, is going to be d less than f of a is. And so this just continues like this, meaning that we're always having the same common difference between all of these terms. So if I'm asked to define a sequence recursively, one of the big things I want to know first is what is that common difference? And there's a very simple way to find that. So let's take a look at this a sub n sequence here. If I want to know what the common difference is of those elements, all I have to do is take the second element and the first element and subtract them. So let's do that here. I'll take the second element minus the first element. And in that case, I'm going to get 0 minus -2, which is 2, right? So I suspect that the common difference is 2. Now, in order to confirm that this works for the whole sequence, I'm going to do the same thing with the third term and the second term, right? Because if this term minus this term is 2, then this term minus this term should also be 2. So let's check and make sure that that's the case. Are these equal? Well, my third term is 2, my second term is 0, and so I do get 2. So it checks out. Therefore, we're going to say that our common difference is 2. Now I can define this thing recursively, but when I define recursively, I always make two statements, as you saw in the Khan Academy homework. So the first statement is a very simple statement that just says what our first term is, and our first term is -2. So that's easy enough. But our second statement has to tell us how to find any term we want to using the pattern that exists. So my second statement is going to say if I want to find the nth term, and now I have to state what I have to do to the previous term if I want to find the nth term. And we know that that rule is take the previous term and add 2. So the way that I'm going to write that in subscript notation is I'm going to say take the previous term, which is defined as a sub n minus 1, and add 2. Because if this means the nth term, then this means the term right before that, right? If n is 7, then this means the 7th term. And 7 minus 1 is 6, so then this would mean the 6th term. And so this right here is a recursive definition for this sequence, and I could use it to find any term I want to. It would just take some time because I would have to find the 6th term to find the 7th term. And in order to find the 6th term, I would need the 5th. In order to find that, I'd need the 4th. So it takes some time, but at first we are going to define these strictly recursively. So let's take a look at the b of n function over here. Notice these notations are different. That doesn't matter. Sometimes sequences are written in what is called subscript notation like this. Sometimes they're written in function notation like this. It doesn't make a difference at all. So let's say I suspect that this is arithmetic, but I don't know for sure. I can run this little test like I did in the previous example. I know that I've got a first term, a second term, and a third term. And as long as I have that, I can test to see what type of sequence this is. So I'll do exactly what I just did in the last example. I'll take the second term and subtract the first term and see if that's the same as the third term minus the second term. And if it is, then it's arithmetic and I'll have found my common difference. So my second term is 5.6 and my first term is 3.2. And when I subtract those, I get 2.4. All right, my third term is 8 and my second term is 5.6. And when I subtract those, I get 2.4. So it is an arithmetic sequence because there is a common difference. Now I can define this recursively. So when I define it recursively, I'm going to start off by just saying the first term is 3.2 because that gives me a foundation to build this sequence from. And now I want to give instructions for how to find the nth term. So the nth term is the result of taking the n-1 term and adding 2.4. So I'm going to say that to find the nth term, I'm going to take b of n-1, because that's going to be the term right before the nth term, and add 2.4. And now I have a rule that can help me find any term I want to in this sequence. So that's just a general overview of arithmetic sequences. Now let's talk about how to handle this if our sequence doesn't involve addition or subtraction. So these sequences here are going to be geometric, and we're going to make a couple up. You'll be dealing with some of these in your homework tonight. So a geometric sequence is just a sequence that involves multiplication, or maybe even division, rather than addition or subtraction. It can't also involve addition or subtraction. It's got to be strictly multiplication or division. So in this case, if I had a sequence, and I'll call it f of n using function notation, doesn't make a difference, I'd have a first term, and I'd have a second term. But in this case, it would not have been addition that would have gotten us to that point. It would be times some number, and we're going to call that a common ratio r, right? And that would continue. There would be a common ratio r connecting these two terms, and I'm just going to keep multiplying by that common ratio r until I get to whatever term I want to stop at, and that pattern just continues. So let's do the same thing we did. I'll make up a couple geometric sequences here, and we'll define them recursively. All right, so we're asked to define the following sequences recursively, and I suspect that they're geometric. So this time, when I do my test, I still have my first three terms, but I'm not going to subtract them to test for a common ratio. I'm going to divide them. So I'm going to take my second term and divide it by my first term and see if that's the same thing as the third term divided by the second term. If it is, then I've got a common ratio and I can work with that. So let's see, the second term is 8, and the first term is -4, and the third term is -16, second term is 8. If I do this division and simplify these, I get -2 and -2. So therefore, my common ratio is -2. That means that as this sequence progresses, it's times -2, times -2, times -2, and so on. So when I make my recursive statement, I'm going to say that the first term is -4, and the nth term is the result of -2 times the previous term. I take the previous term, multiply by -2, and I get the nth term. So I'm going to say times c of n-1. And you don't even need that little multiplication dot there, but this gives you a way to find the nth term. So if you're looking for the 8th, you need the 7th still, but you could still do that by finding the 6th, and you can find that by finding the 5th, and so on. All right, the last one here. Let's again test to see if there's a common ratio. I want you to do that on your own, and then pause the video and see if you're correct. So I'm going to test to see if the second divided by the first is the same as the third divided by the second. And the reason I'm using division and not subtraction is because I suspect that it's geometric. not arithmetic. And if it's geometric, that means multiplication or division. So I'm going to set this up here. That's going to be 12 divided by 18 and 8 divided by 12. And this looks a little trickier, but if I reduce these fractions, 12 and 18 are both divisible by 6. So I'm going to have 2/3 there when I reduce it. And 8 and 12 are both divisible by 4. So it turns out I do still have a common ratio. And what that means is that from one term to the next, it's 18 times 2/3, 12 times 2/3, and the next term will be 8 times 2/3, and so on. So if I want to give a recursive definition, I'm going to say that the first term is 18, and to find the nth term, I'm just going to multiply 2/3 by the previous term. So tonight in your homework, you'll be practicing defining these sequences recursively. You're just going to have arithmetic and geometric sequences, but we will talk about other types of sequences eventually as well.